Hi there and welcome to the Chaotic Classroom. This video is our second video on the scientific method, and in this video we're going to deal with the most common things that use variables: the aim, the hypothesis and the conclusion. And the problem is these three have a tendency of sounding the same, so I'm going to help you figure out which one is which. Now remember, before you can start working with the aim, the hypothesis and the conclusion, you need to know what is the dependent variable and what is the independent variable. You need to know which one's the cause and which one is the effect. Now first let's start with the aim. Now remember, the aim is usually written before you do any kind of experiment. It is the one where you're going to say, well, why are we doing this particular investigation? What do we want to know? Now there are certain keywords that you can look out for to see if something is an aim, or certain keywords you need to add to make sure that the examiner understands that this is the aim. The most common ones are to determine, to investigate, or to test. And remember, the aim needs to contain both the dependent and independent variable. That's why you need to know which one is the cause and which one is the effect. So let's have a look at an example of that. If we have a look at our first example, it says, a test was done to determine, there's our keyword, the best baking powder to use for a high cake. So what do we have? We have to determine, so it tells us it's an aim, baking powder, and the height of a cake. So there's a cause and effect. The baking powder is going to cause the height of the cake. There's our two variables. In our second example, we have some learners that did an experiment, and here we're going to say to see. So now it's not one of the common ones, but we're still going to do something to see if salt will affect the rate at which ice melts. So what did we do? The presence or absence of salt, that's our cause, and the rate at which the ice melts, that will be our effect. So we're ticking all of the boxes there. Next up, we have the hypothesis. Now this is the question that is asked by far the most often by examiners. Now the hypothesis is asking, what is your prediction? But remember, science isn't personal, so you can't start by saying, I predict. You just need to say, what is your hypothesis? Now first up, it has to be a statement. So it's not a question, it's not something vague, it has to be a statement. Most of the time it's written in future or present tense, and again it needs to contain both the independent and dependent variables. It needs to have that cause and effect in the statement. So let's have an example of what a hypothesis looks like. So now on our first one it says, the more sugar you add to the dough, the higher the bread will rise. So can you see, it's a statement, it doesn't have a question mark or anything. We didn't use those keywords from the aim like to determine or to test. And you can see that cause and effect. Sugar is our cause, the bread's height will be our effect. In our second example, we have something like drain cleaner will have a higher pH than vinegar. So what is our cause? The drain cleaner or the vinegar. What will be our effect? The pH of those. And then lastly, we get to the conclusion. This is the one we don't ask it very often, but it's usually the one that a lot of people confuse, because now we're asking, what did you learn from this? And the conclusion is usually drawn from data, which means that you're going to have to look at the numbers, look at the graph, look at the table. And this one, and that's why it's written in present tense or in past tense most of the time, because you already did the experiment now. Now you have to say, well, what did I learn? And what does it need to do? It needs to contain both the independent and dependent variable. It needs to have that cause and effect. So can you see how important those are? I hope so. And there's an additional bullet here. With the conclusion, try to avoid numbers if possible. Okay? Only discuss the trend. Numbers usually have to do with results. And we're not asking for the results of the experiment. We're asking for the conclusion. What did you learn? So let's have a look there. In example number 1, it says, when salt is added to ice. So now you can see that it's already, we already did this. When salt is added to ice, it melts faster than salt with no ice. So you can see, it's not really a prediction. It's not saying what we're going to be doing here. You get the feeling we already did this. We came to a conclusion. We learned something. And in example number 2, plants produce oxygen during the process of photosynthesis. So we figure out, we did the experiment. We figured out that oxygen is being given off during this process. So I hope this helps. Thank you for visiting the Chaotic Classroom.